In this section, we're going to learn to do some counting techniques. Okay, so we've got a multiplication rule. We have what we call permutations, and we have combinations. So you're going to see the word independent. So for example, if you roll a six-sided die, that's one dice, and flip a fair coin, how many possible outcomes do you get? So when two or more events are independent, the total possible outcomes are the product of the number of outcomes for the individual event. Let's talk a little bit about what it means to be independent. Okay, so the occurrence, it's better, I think, if you have this in writing. An independent event is the occurrence of one event does not affect the probability, I'm going to abbreviate that, of the occurrence of the second event. So just think about, we'll talk about this clothes problem here. If Angela has 9 blouses, 8 skirts, and 13 pairs of shoes, and we want to look at how many outfits she can take or make, it doesn't matter if she picks a blouse, it's not going to affect the probability of her picking a skirt or a pair of shoes. She doesn't care anything about matching. So that would be something that's independent. You've got the occurrence of an event does not affect the probability of the occurrence of the second event happening. So let's go back up here, okay? So if you have 6 rolls, then times 2 flips. If you roll a 6-sided die, so you could roll one of the 6 faces, and you could flip a fair coin, which has a heads or a tails, both sides. So what you do then is multiply those together, and there are 12 possible outcomes for that event. So now let's look at Angela. She's got a closet full of 9 blouses, 8 skirts, 13 pairs of shoes. How many potential outfits can she create? Well, she has 9 blouses, she has 8 skirts, she has 13 pairs of shoes. She doesn't care if they match. Okay, that's not the point here. The point is to come up with how many possible ways can she put those clothes together. And that means then that she has 936 outfits, okay, of 1 blouse, 1 skirt, and 1 pair of shoes. All right, let me go back to independent just a second and talk about that. If you've got that 6-sided die, it doesn't matter if I roll a 3 here, that is certainly not going to affect the probability of getting a head or a tail in that second event. So it's just one of those little things that we talk about in probability, and I wanted to make you aware of it if you come across that verbiage again. So let's look at this kind of idea. How many 5-character license plates can be made if the first 3 characters are letters and the last 2 are digits? So I've got 5 characters. Helps me to draw the lines. I'm allowed to have letters. First 3 are letters, and the last 2 are digits. Okay, the first letter, now if you think about this in the English language, and I know sometimes you just forget this, we've got 1, 2, 3, 4, 5, we've got 6 letters here. In the entire alphabet from A to Z, okay, we've got 26 letters. Okay, so here we've got letters. Now notice it says the first letter can only be a P, a W, an E. I think that is a Q, an L, and a K. So there's 6 ways that I can determine the first digit. Now, the last two, they don't care. It can be any one of these. We can repeat these, or it can be any other of the letters. So there's 26 of those that can happen. Okay, so then we need to think about the last two are digits, single digits. So if you think about that, we've got 0 through 9, which is 10 digits. So there's 10 ways that can happen and 10 ways that can happen. So then what we want to do is multiply those together. So I have 26 times 26 times 6 times 100, which is 405,600 license plates. Can be made. Okay, now it wouldn't surprise me, just for something to be aware of in the license plate land, they might throw out the O, the letter O here, or they might throw out the letter or the number 0 here. If they changed this and said, we're gonna allow a digit, but we're gonna omit the 0, then what you would do would put a 9 here and a 9 here. So just be aware of that. It's really easy to mistake the letter O and the number 0. So let's move on. A menu has 6 different breads, 3 different salad mixes, 5 different dressings, and 8 different soups. In how many ways could you order your soup, salad, and breadsticks for lunch? Well, there's 6 different breads, there's 3 different salad mixes, there's 5 different dressings, and there's 8 different soups. So when you multiply that all together, I'm pretty sure that is 720. That's 18 times 40, which is 720. So there's ways to order a soup, a salad. Now, this isn't like getting 2 salads. This is a soup, a salad, and a dressing for the salad, and breadsticks for lunch. So this is what we're looking for, 720 ways for that to happen.